This is Giancoli Chapter 9, Problem 47, and we have a steel wire, 2.3 millimeters in diameter, that stretches by 0.03% when a mass is suspended from it. The question is, how large is the mass? So here's our picture. We have our diameter steel ring here. It stretches a little bit when we add a mass onto it, and the question is, well, how do we find the mass after being given these few items to solve with? Well, so the mass can be calculated from the equation for the relationship between stress and strain, and there's obviously a force associated with this mass, right? So since gravity is going to be acting downwards here, then we have to include gravity. So there will be a force due to gravity on the mass here, pulling downwards, right? So with this force and with our knowledge of Young's modulus and how it relates and the relationship between stress and strain, we can apply equation 9-4 here from Giancoli's book. And we can see that the force causing the strain is the weight of the mass, which is suspended from the wire here. So key points, you want to use the stress and strain relationship, which is equation 9-4. And the force causing the strain is the suspended weight. So we want to use this formula where delta L over L naught equals 1 over Young's modulus multiplied by the force divided by the area. So the area for a circle is going to be pi r squared. So we'll take this number and we'll split it in half into 1.115 and convert it to meters. So we'll add a times 10 to the negative 3 onto it. So we convert it to meters and then half it, basically, for the area. And E will be given to us in the table, in the book, in the table 9-1. You'll look and find 200 as the number that fits there. And the rest is calculable. The mass we know. Oh, no, the mass we don't know. So, yeah, G we know is 9.8. And then we move everything else around so that we can find the mass. So here we'll multiply both sides of this equation by EA. And so we should have EA times delta L over L naught, which is also divided by G now, to give us M. We'll see that here. Yeah, so M is equal to EA over G times delta L over L naught, with everything plugged in here. And yes, so if you plug in all the numbers, 200 times 10 to the 9th newtons per meter squared times pi times the square of 1.15 times 10 to the negative 3 millimeters multiplied by 0.03%. Divided by G times 100, it will give us about 25 for the mass. So the mass that was suspended here is 25 kilograms.